Hi guys, my name is Trevor Sullivan and welcome to another CBT Nuggets skill where we are going to continue our learning about the Kubernetes platform. In particular, on this particular skill, we are going to be using Kubernetes on Amazon Web Services. However, we're going to be talking about a concept known as the Ingress resource, an Ingress controller, that allows you to basically route traffic in a cloud agnostic manner. Now, Amazon Web Services does have their own Ingress controller, but in this case, we're actually going to be taking a look at an open source Ingress controller that's actually managed by the Kubernetes team. It's called the Kubernetes Nginx Ingress controller. And this is a cloud agnostic method of routing traffic to different services that are running inside of your Kubernetes cluster. But before we get too deep into talking about the Ingress resource and the Ingress controller, first let's understand how services work so that we can kind of compare and contrast how a typical service works versus how the Ingress feature works in Kubernetes. So for starters, we've got a basic Kubernetes cluster here, right? We've got some master nodes here, and we've got some worker nodes. And you could be running this cluster in a EKS environment, Elastic Kubernetes environment in AWS, or you could be running it as a self-managed cluster. But in this case, we're actually going to be talking about it from the EKS perspective because EKS in AWS is nice and tightly integrated with the AWS platform, in particular the load balancer feature that allows us to route traffic to different pods that are inside of our cluster. So for starters here, let's say that we want to deploy an application. Let's just come up with some basic web application. It could be a note-taking application. It could be a music player application, really any type of application that you could think of. And of course, we are going to package up our application in pods. And in Kubernetes, each pod can have one or more containers inside of it. So a pod and a container don't have a one-to-one relationship. And that's really important because when you deploy a pod as a unit out to a worker node, that pod could contain more than one container. Maybe one of those containers has your actual application, like a web service that you're deploying. And maybe the other container that's inside of that pod is perhaps a logging agent, and it's gathering logs from your application and then sending it off to a logging service like Elasticsearch or Amazon CloudWatch or some other logging service like that. So first of all, we're going to just deploy out some pods here, right? And you could do this using a replica set. You could use it doing a deployment controller, which I've actually got a separate skill on that goes into more depth on what deployment controllers are. But let's just say that we've got a couple of pods that we've deployed out to our environment here. And we've got two different pods running our application. And I'll just leave that third one kind of off to the side for now, just to keep things a little bit more simple here. And then in order to expose this application to external users of this cluster here, we need to expose it outside of the cluster, right? We need to get access to that service outside of the Kubernetes cluster itself, because right now these pods are just going to have IP addresses on the Amazon VPC that our cluster is a member of. And I probably should have drawn a VPC around this, but if you're familiar with EKS, it is deployed into a VPC or virtual private cloud, and that is basically your virtual network layer, your software-defined network that encapsulates the cluster and all of the resources. So each of the master nodes, each of the worker nodes, each of the pods using the VPC container network interface, they all get IP addresses on that virtual private cloud. Now, in order to expose this application to somebody who's coming in externally across the internet, we need to deploy something known as a service controller. Now, a service controller in Kubernetes basically allows you to expose an application either using something known as a node port, which basically you can take these pods and you can expose them as ports on the actual worker nodes themselves. So each of the worker nodes would then be listening on, maybe port 31,215 or something like that. And you could access that application by hitting any of those worker nodes in your cluster on that particular port. Now, the other option that you have with the service controller is to use the load balancer integration with the different cloud vendors that are out there. So, you've got Google Cloud, you've got DigitalOcean, you've got Linode, you've got Azure, you've got Amazon Web Services, of course. And the service controller will basically automatically spin up a load balancer using the cloud platform that you are currently running your cluster on. So in this case, if we're deploying on an Amazon Web Services environment in EKS, for example, then this service controller, we can configure to basically point to both of these pods, and it's going to basically route traffic over to both of these pods using a selector. But then in order to actually expose the application out to the internet, the service controller will actually create a load balancer. Let me bring a load balancer right down here. And by default in Amazon EKS, the service controller will create what's known as a classic load balancer. That's kind of the traditional EC2 load balancer that does layer 4 load balancing. Now, since the release of the classic load balancer, Amazon Web Services has actually come out with the kind of load balancer v2 capability, which gives you the network load balancer, which is still a layer 4 load balancer, but they also give you an application load balancer, which operates at layer 7. Now, we're not going to get too deep into either of those load balancers, but I do just want you to be aware that the service controller deploys a classic load balancer by default, unless you explicitly configure the network load balancer or the application load balancer. Now, once that load balancer is deployed, it gets a DNS name that your users can access directly across the internet. And so anytime that your users are accessing this load balancer, let's bring in some users down here. So if we've got users that are, hitting this load balancer on, let's say, port 80 externally on that DNS name, then the load balancer will then route traffic to the service, and the service is going to basically configure that load balancer automatically to route traffic to these different pods that are actually backing this service itself. So anytime that maybe a new pod gets spun up, the service controller will add that additional pod to its rotation and then register that third pod with the load balancer so that when these users are pinging that load balancer on its external endpoint, the load balancer knows that it's able to route traffic to this additional pod. And of course, if a pod was destroyed, then the service controller would go back to the load balancer and say, hey, I just want you to know that this pod is no longer existent, so you need to stop routing traffic to that pod because you're going to result in either a timeout or some application error that's going to result in end user confusion. So that's kind of how the traditional service controller and load balancer mechanism works in Amazon Web Services EKS. Now, what gets more interesting here, well, before we get into that, the service controller is actually an a layer 4 load balancing capability. So basically, we're just kind of balancing traffic across multiple pods that have the same IP or have different IP addresses. And so it's not doing really any intelligent routing here, aside from saying that, port 80 on the external side of the load balancer gets routed to port 80 on one of these pods over here that's running this service. So it's not really doing any intelligence in terms of saying, okay, if the traffic coming in is asking for, service 1.cbtnuggets.com, then I need to route to this service. Or if the request is coming into service xyz.cbtnuggets.com, then I need to route to this other service instead. And so that is HTTP layer 7 load balancing that is occurring. And that's what the Ingress controller allows us to accomplish. So let's talk about the Ingress controller in a little bit more depth here, because the Ingress controller is going to allow us to do layer 7 load balancing instead of just simple kind of dumb layer 4 load balancing that's just rotating around different pods. So essentially what we would do is with the Nginx load balancer, this is a project that's actually maintained by the Kubernetes team, and it is cloud agnostic as well, so that's really convenient. So you can use it on different cloud vendors. So basically what you do with an Ingress controller is you start out, this is going to be you here, you're kind of the administrator here who's doing all the administration of this environment here. And what you as the admin are going to do is take this Ingress controller and you are going to deploy it to your Kubernetes cluster for starters. So you're going to take this Ingress controller, you're going to deploy it out to your cluster and basically register that Ingress controller with your Kubernetes cluster. Now, that doesn't really do anything in and of itself except kind of prepare your cluster to use the Ingress resource in Kubernetes. And that is a particular type of resource that allows us to do layer 7 load balancing. So this is the Ingress resource right here, just the documentation for it. And you'll see here that we have kind of the client coming in, and then we've got the Ingress managed load balancer that goes into this Ingress resource, and then the Ingress resource is able to make intelligent decisions about the incoming request and route to different services. Now in this little diagram here, they just have a single service, but over here in my diagram, I've got 2 different services. So imagine that, you know, one client is coming in to service1.cbtnuggets.com in their web browser, and so that request could get routed through this Ingress resource to go to service number 1. I'm just going to duplicate this here. So we have the service XYZ, and we have service 1. And so let me just delete this connection between the load balancer here. So if I've got a request coming into service 1, then I can route that to the service 1 service right down here. And he has a couple of pods right over here. And I'm going to duplicate these pods down here, and we'll say this service XYZ also has a couple of pods registered with it as well, running a different application, of course. And if a request comes in from a user up here for the service XYZ instead, let me just send these to back really quick so we can see things a little bit more clearly. So if we have a request that comes in to servicexyz.cbtnuggets.com, then the Ingress resource can then route that traffic over to the appropriate service. So that would be, of course, the service XYZ service right down here. So that's kind of what the Ingress resource does, is it allows us to make decisions based on the host name or the URI path that's being requested by a particular client. So in this particular case, we have 2 different host names, service1.cbtnuggets.com and servicexyz.cbtnuggets.com. Those are 2 different host names or DNS names. However, you can also do path-based routing in an Ingress resource, which is still using the layer 7 load balancing. And so you could say if something comes into cbtnuggets.com/service1 versus, you know, cbtnuggets.com/service2, then you can use the path portion of the request right here, which is basically just these last few characters after the / here. You can use that path to make decisions about where to route that traffic to as well. So very similar to how we can do hostname-based routing, we can also do path-based routing as well. So those are the options that you have with Ingress controllers. And then basically what you do is you deploy your different applications, right? You deploy your pods, you deploy your service controller for, you know, multiple services down here, and then you create this Ingress resource, and this Ingress resource is what contains this logic right here. So really these requests are kind of being passed into the Ingress resource, and the Ingress resource is making those decisions about which of these services it should be routing traffic to. Now, keep in mind that when we use an Ingress resource, it actually still does use a load balancer on the outside. So when you create an Ingress resource, it will be accepting traffic coming in from a layer 4 classic load balancer. However, the Ingress resource is what actually does that layer 7 based routing. So it's a much more powerful capability than what you have just purely with a layer 4 load balancer. Now, one other thing you can do with the Ingress resource as well is to obtain certificates. So if you want to do TLS encryption on your endpoints, then you can configure the Ingress controller to actually request certificates. There's actually another component out there that you can deploy as an open source project called Cert Manager. And you can configure Cert Manager to basically go out and request TLS certificates for your public domain names from services, Acme-based services like Let's Encrypt, for example. And then your Ingress resource can then have those TLS certificates on them so that your requests that are coming in from your end users over here into the load balancer and ultimately through the Ingress resource can then have TLS termination being done at the Ingress level. So what we're going to do in the rest of the skill is actually take a look at how to do this in practice. We'll spin up an EKS cluster right over here, and then we'll deploy a service as a couple of pods. We'll of course create the service controller as well, and then we are going to deploy the Nginx Ingress controller to our Kubernetes cluster. And then we will create this Ingress resource with the routing rules, the layer 7 routing rules, and make sure that we are able to route traffic from a domain name out to a particular service that's running on our cluster right down here. I hope this has been informative for you, and I'd like to thank you for viewing.